All right, so here is the answer key for this review here. All right, so number one, what are the factors and the roots of this polynomial? So we are going to factor this. When you look at all these three parts, they all, every single one of these pieces will divide by 2x, the GCF. So we are going to pull out that 2x. So let's see, f of x, I'll pull out 2x, which means I have x squared minus 10 divided by 2 is 5 with 1x left. 12 divided by 2 is 6 with no x's left because it's out front. All right, and then keep going. 2x, this will factor again. If you need to, you can go ahead and put your -6 and -5 here, which means you'll have 6 and 1. So -6 plus 1 to make that come true. So x minus 6, x plus 1. So my factors are 2x, x minus 6, and x plus 1. My zeros, or my roots, are 0, 6, and -1. Because what makes this part equal 0, remember I take x minus 6, set equal to 0, and solve that. That's how I get 6. X plus 1 equal to 0, take away 1, get x equals -1, so that's how we got that one. And here, 2x equals 0, divide both sides by 2, and you get x equals 0. So there's that third one. And also remember, third power means you have most likely 3 answers unless one of them's a double root. All right, over here, the only thing I can take out is an x that they have in common. 2, 5, and 7 do have nothing in common. It's pretty much the same question as number 1. So f of x, we'll pull out an x, which leaves me 2x minus 2x squared minus 5x minus 7. So when I factor that, basically I'm just left factoring this part. So 2 times -7 gives me -14 up here and then -5 there. So we'll do 7 and 2, -7 plus 2. So when I go to factor that, my x minus 7 and my x plus 2, remember that I have to divide these things by 2 to get the real answers. So when I put them over here in my problem, I will be writing 2x minus 7 and x plus 1 for those factors. Let's just check that out. 2x squared, this is 2x minus 7x, which is my -5x, and -7 times 1 is -7. All right, so it's ready to go. So factored form is x, 2x minus 7, and x plus 1, which means my x-intercepts, or zeros, are 0, positive 7 over 2, and -1. Now 7 over 2 is also 3.5. So remember, if you wanted to check these answers, you would just go to Desmos and plug this in. Instead of f of x, you would put y equals, but you'd type this in and you could see the x-intercepts and turn them right back into factors. And same thing for this problem here. All right, with number 3. With number 3, the factors and the solutions of this polynomial. So in this one, notice that we have 1, 2, 3, 4 parts. So the only way that we know how to do this for now, later there will be other things, but for now, the only thing you know how to do is the factoring by grouping. So we're going to split this down the middle. So that means I'm going to be looking at this first item. These have x squared in common. So I'm going to say I'm pulling x squared out, which leaves me x minus 3. Always put the same sign, minus, and what do these two pieces have in common? They have a 4 in common, which leaves me as, -4x divided by -4 is x, and 12 divided by -4 is -3. So then hopefully you notice that, and this has to happen, that these two pieces match, right? And if you were to multiply this back out, for instance, if you multiply this back out, you get exactly what was up here. All right, so now those two pink pieces are what I'm going to take out. X minus 3 to factor those out, which leaves me x squared minus 4. Now x squared minus 4 can be factored again. So x minus 3 stays, and x squared minus 4 factors into x plus 2 and x minus 2. So there's my 3 factors. I got x plus 2, x minus 2, and my solutions are 3, -2, and +2. Okay, my x-intercepts basically. All right, over here, same thing, 4 parts. I'm going to have to break this apart, do factoring by grouping. So this group right here, I have an x squared in common, which leaves me x minus 5, minus again. For this group, I have a 9 in common, and what's left is x minus 5. Okay, so I pull out the x minus 5 they have in common, which leaves me x squared minus 9. So that means I have x minus 5, and x squared minus 9 factors again into x plus 3, and x minus 3. Now, they won't always factor again, but these two, they do. All right, so the factors are x minus 5, x plus 3, and x minus 3. And my zeros are 5, negative 3, and positive 3. Oops. All right, so that means that if I were to graph this right here on Desmos, I would see x-intercepts at these 3 places. And because it's a cubic function, we actually kind of know more about this graph. So I can even sketch like a little graph right here. It crosses at negative 3, positive 3, and 5. And it's an odd power, x to the third, so it means that the right side goes up, the left side goes down. And frankly, this is going to come and turn around like this and like that. So the graph has that pretty much that shape to it. All right, and you know, like it goes higher. Like this is actually just going to cross at 45, but you know, not worried about that, but just worried about the general shape of it. All right, down here, back to some old stuff. So these are all quadratic equations. They are polynomials, but more specifically, they're quadratics. And so remember that we were able in chapter 2 to go ahead and figure out what kind of solutions there were going to be, all based on the discriminant. So that's with this information right up here. And here my discriminant. My discriminant is the part inside the radical right there. Okay, so here, my a value is 2, my b value is negative 5, and my c value is 4. So my discriminant, the b squared minus 4ac, goes like this. Negative 5 squared minus 4 times 2 times 4. So if I just figure that out, so that would be what? 25 minus 16 times 2, so 32. My discriminant is negative 7, which tells me that there are no real solutions. This graph has a positive 2x squared, so it's going to be facing up. So what's going to happen here is this graph is going to be above the x-axis. It's not going to touch the x-axis at all. All right, here, my a is 1, my b is negative 6, my c is 9. So b squared, so negative 6 squared minus 4 times 1 times negative, just times 9, sorry. So it's 36 minus 36, which is 0. So what that tells me is that there is one real solution. So when the number underneath the radical is 0, what happens is that this whole part goes away because it's just 0. So my only answer is negative b over 2a. So in this type of graph, this type of picture, what's going to happen is it's going to touch the x-axis once, called a double root. Touches once and leaves it at the same time. All right, over here, a is 5, b is 2, c is negative 7. So 2 squared minus 4 times 5 times negative 7. So that's 4. 2 negatives turns into a positive. And let's see, 20 times 7 basically. So that's going to be 140. That's going to be 144. So it means there's going to be 2 real solutions. Now, I don't know what the graph looks like, but I do know that it's going to have 2 real answers, so it's going to cross the x-axis 2 times. It might both be on one side of the x-axis or the other, or it might be kind of split apart like this, but there's going to be 2 answers, 2 real solutions that I can see. All right, down here, factoring. So notice these guys, these are perfect cubes. So remember, this is m being cubed, and this is the number 3 being cubed. So what we do is we take those parts in a little piece, and then we have the big piece. So I take the m that I cubed, and I take the 3 that was cubed. Those are the things that are being cubed to make this. Then remember over here, we do square, multiply, square. There's our little pattern. So I take m and I square it, which gives me m squared. Then I take this m and the 3 and multiply it together. That's what this multiply means, so 3m. And then we take this 3 and we square it. So 3 squared is 9. And then we do our SOAP. Remember, SOAP stands for same, opposite, always positive. So for the first sign, I'm going to do the exact same sign that this is. So I'm going to put that right there. So minus, and then opposite sign is positive, and then always positive. So this is the factoring of those two cubes, the difference of those cubes. Over here, this 8x to the third plus 125. So what's being cubed here is 2x. 2x is being cubed. Then over here, 5 is being cubed. So those are my two pieces. So 2x and 5. Notice I'm not putting the sign until the end. So over here, I'm again going to do square multiply square. Okay, so take 2x and square it. So 2x squared means I'm going to have 2x squared, or I could write 2x times 2x. Either way, it's 4x squared. Then I multiply them together. So 2x times 5 is 10x. And then I square the 5, so 25. All right, then my signs, same, so plus, opposite, always positive. All right, for this next one, number 7, this is back to chapter 3. Determine the solution of the systems of the equations here. The solutions to the system of equations. So these right here are two parabolas. The top parabola, x squared minus 2x minus 1, is facing up. The bottom one is facing down. So I'm going to get some situation, most likely, that one's facing up, one's facing down, and they're crossing in two places. So I've gone ahead and you'll do this on your test. You'll graph those in Desmos. And so I have them here. So let's zoom in there. Let's see. Remember, I don't care about the x-intercepts anymore. I don't care. I don't want to know where they intersect each other. Ooh, so these are not pretty. So those are your two x-intercepts right there. I'm sorry, those are your two solutions. So when you write the solution, you'll go ahead and put the whole answer. So like 2.7 and 0.8 looks like. And you'll put the second solution as well. Negative 0.2 and negative 0.6, we'll say. All right. So, last page here. All right, number 8, another good old flashback. So here we're doing composition of functions. So remember, somebody writes f of g of x. It means f is the boss. So he's the boss. You're taking g and you're putting it right here in place of the x, in place of the x. So f of g of x goes like this. I write f down. I write this down. 2 something minus 8. And in that spot, in that empty spot where I said something, I'm going to be putting g of x in there. So negative 3x plus 4 goes right in there. And then I just work it out. I just go ahead and like multiply it out. Let's see, this makes negative 6x plus 8. Then I got a minus 8, so it works out to negative 6x. And that's my answer. All right, down here for g of f of x. So g of f of x. So that means that g is the boss. So that means I'm going to write this down. Negative 3 something plus 4. Now in place of that something, I'm going to put f of x right here. That goes right there. So 2x minus 8. So let's work that out. So I get negative 6x plus 24 and then plus 4. So I get negative 6x plus 28 by the time I'm done. And that's my answer. All right, number 9. Number 9, we are going ahead and do the quadratic formula the whole way through. So a is 2, b is negative 4, c is 3. My discriminant, remember, is b squared. So negative 4 squared minus 4 times a is 2, c is 3. It's always a good idea to figure that out first. So 16 minus 24. So I get negative 8. All right, so here we go. My answer is opposite of b. So I'm getting this from the top of the last page, the formula. So opposite of negative 4 is 4, plus or minus the square root. And look at that, I already have the negative 8 over 2 times a. Well, 2 times 2 is 4. So let's reduce this. 8 can be broken down into 4 times 2, and then 2 times 2. So there's a 2 coming out and a 2 staying in. 2 coming out, 2 staying in. So I go 4 plus or minus 2i, radical 2. Now remember, that's an I right here because there's a negative coming out. Negative under the radical. All right, so now take a look. These 3 pieces all reduced by 2. So we're going to do that, and I'll be done. So I got 2 plus or minus 1i radical 2 all over 2. You cannot touch the 2 inside the radical, and that is it. All right, for number 10, I'm going to go ahead and work these all the way out, but remember you can just type this right into your calculator. So multiplying, I have to FOIL this to work it by hand. I'll get 10 plus 30i, inside minus 6i, and last part minus 18i squared. So the only thing to remember, I squared is equal to negative 1. So this will be 10. 30 minus 6i is plus 24i. And over here I have negative 18, and the I squared makes negative 1. So this right here is really a positive 18. So that 18 combined with this 10 up front makes 28, and then plus 24i. All right. Okay, here, this is just a subtraction. So negative 3 minus I doesn't change. The negative 5, this negative gets given to the 5, and the negative gets given to the negative 2i. So it's negative 5 plus 2i. So let's combine like terms. When I look at this, negative 3 and negative 5 are like terms, so I'll make that negative 8. And then over here, negative I and plus 2i. Negative 1 plus 2 is positive 1i. So there we go. For letter B, oh, there was 2 A's and 1 B. Oh well. I'm going to multiply, just distribute. I'll get negative 20i, and then 2 negatives, so plus 16i squared. But remember that I squared is worth negative 1. So it's negative 20i plus 16 times negative 1. So it's basically negative 20i minus 16, or negative 16 minus 20i. Either way. But remember, you can put those right in your calculator. All right, for number 11, remember that we have to look at 2 things to be able to tell the end behavior. This is where we stood up in class and we were like looking at, raising your arms up. So the first thing that we have to look at is the degree. Is it even or odd? All right, so there's the highest power. Highest power is my degree, and there we go. All right, the next thing I have to look at, so this is going to tell me whether the ends go opposite or the same way. So remember, odd means opposite. So the normal opposite way to go, the normal way to do it is to have the right side go up and the left side go down. But this right here has a negative in front. The leading coefficient's negative. So that means the normal thing gets switched. So that means that the left side goes up. So right here, left side is going up, right side is going down. So these little arrows that we've drawn over here are now the opposite ways. Right side down, left side up. Okay, for letter B, even, they both go the same way. So they both go up normally. And then when I take a look at this piece right here is positive, doesn't change that. So positive is the normal way, so up. So both go to infinity. And then letter C is the same situation. Has an even with that 6, but the 7 is negative. So since that's negative, that means both of these upward arrows turn down. So left side goes down, right side goes down. Now with letter D, it has an odd power again, kind of like letter A, but this time the front number is positive. So that means the right side that was facing up and the left side down, that's going to stay that way. All right, so left side goes down, right side right here goes up. So when somebody says x goes to negative infinity, remember that's over here, that's the left side. When x is going to positive infinity, that's the right side. So that's why I keep saying left side, right side, and all that stuff. All right, let me erase all these little things. Oh, I didn't have to erase that, I guess. Okay, let's see. Last one here. All right, let's take a look at this picture. All right, I see an x-intercept at negative 1. I see another x-intercept at negative 4. Now, this one right here is a double root. So it's passing right through negative 4, but then it's bouncing off of negative 1. So remember, that negative 1 is a double root. It's going to count twice. So my roots, or my zeros, are negative 4 and 1. My y-intercept is 0, 4. When I write my factors, the negative 4 is going to turn into x plus 4. I didn't write negative 1. My negative 1 turns into x plus 1, but it's a double root, so I put a little 2 there. All right, this coordinate right here is, let's see, negative 3, 4. Okay, I'm asking about increasing and decreasing. So this little section right here, increasing. Also this section, increasing. Now remember, when we talk about increasing and decreasing, we talk about the x values. So increasing, this whole section right here is increasing. And this whole section after this point is increasing. Remember earlier in the year we did all this coloring to get this done. Okay, so let's go ahead and say from negative infinity to right here. Well, right there is the x value, negative 3. So that is increasing. And also from this spot right here, which is negative 1 to infinity. So negative 1 to infinity. That leaves us the part in the middle from here to here, this little section in the middle that is going down. So this whole section in the middle is decreasing. So that's from negative 3 to negative 1. Okay, and my end behavior. So left side of my graph right here is pointing down. So left side down, right side going up. So right side going up. And that's all we have to say. All right, I'll see you in class.